Hello. So I'll just get started. Hi, I'm Danielle. That was a close attempt at pronouncing British place names. It's Lancashire. My pronouns are she and her, and I'm a senior engineer on the Nomad team. And if you do the Twitter thing, that's my Twitter. So what are stateful workloads? Stateful workloads save data to persistent disk storage for use by itself and to provide things to other services. And an example of this would be a database or key value store like Redis or MySQL or basically any HashiCorp product. And managing persistent workloads is actually pretty hard. But they're core to basically everything that we all do. If you work on a web service, you will have at least one database somewhere, probably more than you actually know about because someone will have spun something up at some point in time and forgotten about it. And because a lot of these services dictate the actual usability of your application, they're often managed very, very carefully. They often run on dedicated servers separate from the rest of your fleet. And they often go a while without being completely destroyed and brought back up because you're scared of turning your database off, which reasonable. But it often means that there are this mess that you don't actually know how this machine is configured anymore or what the hell is going on. And so when it breaks at 2 a.m. and you're on call, you're just reverse engineering how this machine was spun up 2 years ago. And it's just a really sad time. And it only gets more complicated as your infrastructure evolves. Say that you want to adopt service meshes in your organization. And in Nomad in 0.10, we are just in the process of shipping native support for Console Connect. If you wanted to introduce that to your data plane layer and it's running on some random boxes somewhere, that is a whole new set of stuff you need to set up monitoring for, try and configure, understand how it works. And that's a lot of pain. And they don't benefit from our native integration because they're just running somewhere. But if you separate your database application from the actual underlying persistent storage, then you can actually move that into your workload orchestration and get all of those benefits in your persistent workloads. That can generally help you simplify a lot of your operations. Because you reduce the overhead of having to manage multiple deployment paradigms, unify a lot of your actual monitoring, and also because we provide a lot of operational metrics about research usage, application crashing and logging and everything else, it gets pretty nice. Nomad deployments also give you the ability to coordinate a lot of your upgrades across replicated services. So you can sort of more easily manage rolling out new versions, configuration changes, and you actually get visibility into that through our logging and task events and stuff. And we can also handle a lot of the failure domains. So from handling crashes to handling nodes dying eventually and sort of all of those sad things. But that's all great, but it requires us to have a way of having storage that actually outlives your container. Containers are very ephemeral. It's a CH root somewhere on a disk somewhere. You blow it away and everything is gone, bye-bye. So let's take a look at what you can do in Nomad today before we take a look at where Nomad is going. Basically everything Nomad does with persistent storage shipped in 0.50 2 years ago. So we're going to start out by taking a quick look at the ephemeral disk feature that Nomad has, which has one of these modes that is sticky volumes. And that means that when a node hasn't gone away and you ship an upgrade, we will try and schedule it on the same node and then copy the allocations directory into the new allocation. And so you just have the data there that was already around. This is pretty useful if your application can technically recover its state, but benefits from just having it. And as an enhancement of that, We also have the ability to actually migrate data between different Nomad clients when we reschedule your allocation. But this only works if that node is still healthy. If that node has got away, like, so is your data, which, I don't know about you, but like losing data like keeps me up at night. Like, I've had actual nightmares about losing data before. It's not the best. And some people who use our Docker driver also use Docker volumes to mount arbitrary paths from their machines into their containers, which is like pretty useful if you're using something where like being ephemeral is sort of okay, but like having that data around is nice. Or if you're mounting it onto like EBS volumes under the hood. And Docker volumes also have this concept of their own type of driver. So if you're using something like RexRay, they'll automatically like mount volumes from like EBS or GCP or whatever to the node. But this gets kind of messy if your scheduler isn't aware of things. Like, all of those are like pretty useful features, but they have a few problems. Although Nomad is aware of ephemeral disk when scheduling future allocations, it's not aware of anything about your Docker volumes. Without like configuring like a lot of node metadata and setting up a lot of constraints, like we have basically no way of automatically making sure stuff is placed on the same node. And so like, for example, like if you're using ephemeral disk here, like we should theoretically prefer the green node, which has which is the like previous allocations node, or the yellow nodes where they are close to the data, and so copying it will be cheap and fast, because we want to minimize the startup time of your tasks. And the red nodes are, say, ones that are running like far away, like it's going to be slow to copy the data. Maybe there's some like random network hops in the way. But right now, oh yeah, the happy path is to pick one of the green or yellow nodes. But since we have like no real control over that, or like no real understanding of those types of topologies with your volumes right now, like Nomad could just as easily pick one of the like slow, sad, expensive nodes, leading to longer task startups and like more expensive data transfer, which, if you're doing this a lot, is kind of sad. And like everything I just talked about has literally no way of doing access control. So in the case of Docker volumes and like the way they do host paths, if you can submit a job to the cluster, you have access to all of that data. And with ephemeral disk, if you can submit a job to that namespace, like you can just submit a new thing that replaces it and like bye-bye data. Hello, I liked you, but now you are gone. So like, yeah, you can just be like, please give me the data, run the job, and then you're like, hello, you have my data now. And then you're on like the front page of CNN. I think that's an American news organization. Like, it's a very sad time. And like, we also can't do anything intelligent about failure recovery if we don't understand your data. Like, when a node managing an allocation fails, like Nomad will attempt to reschedule your workload, and then we'll just like try and copy that data because we'll be like, hello, allocation, yes, I want to start you. Where were you running before? And then we'll be like, cool, we'll try and contact you. And that node is just like lost in the like sadness that is like commodity cloud hardware. And then we can't go and refetch that data because the node is gone, and your application now needs to recover that data or do something. I hope you had backups. So like, what do we do to improve this? Because although we have some stuff that lets you get what you want done, like, it all has some limitations. So in Nomad 0.10, which went into beta yesterday, we're actually shipping support for mounting volumes from Nomad clients into your tasks natively, which solves some of the scheduling and security components, as well as giving us a way to mount volumes into your tasks regardless of their driver. So, like, yeah. What we want to do is enable mounting these volumes from your host across any test driver with like native understanding of scheduling, So we can have like read-only volumes, writable volumes, and like some other nice things in the scheduling layer. And also have access controls that can limit the mountability and various access types of that data. So how do we actually make that work? To expose a volume to your cluster, you include the new host volume configuration stanza in your client config. This gives the volume a name. And you can also specify if users should be only able to use it in a read-only fashion, regardless of their ACLs. And just like with namespaces, volumes are keyed by their name, and you can specify a glob of volumes that an ACL policy should apply to, as well as whether like, that policy allows read-write access or read-only access to volumes when available. And then in your job, you specify that your job needs a volume, that it's a host volume, that you only want read-only access, and like the source volume that you should be trying to find. Then in any of your tasks, you can choose a different mount point for your volume. So in this case, we mount it to etcssl certificates in our like Nginx application, and then we go and run the task, and like everything is happy, and it gets mounted in. And if I can make computers work, I now theoretically have a demo. 1 second. Oh no, I've probably just broken everything. I don't like computers. Okay, that is the right thing. That is probably way too small. Can I? Cool, if I look over there, then I can see the screen. Let's do some fonts. This is very live. Let's go for 18.
Actually, it's okay back here.
Oh, really? Cool. That makes my life easier. So I will go and restart this because computers are doing a thing. I thought I stopped you. Come on. Come on, Docker. Stop some containers, please. Come on. Yay. Nomad agent-dev. So I'm going to spin up a dev agent, and we also have console running in the background. Then I will just zoom in here. We have a couple of different jobs. So in the config, we expose a volume, which points to temp HashiCorp demo and exposes it as MariaDB A. Then, I cannot type. Then if we take a look at the MariaDB job, we specify that we want this volume. And then we mount it into the task in the var-lib-mysql. We have a very secure root password that is generated by Vault, pulled into the task. It's all magical. And then we have some things, and the rest is just a regular Nomad job that exposes a service to console. So if we go ahead and run that, Nomad run, and then also take a look at our node, you see that the node exposes the MariaDB host volume. And if we dump this out in verbose mode, too many things. We also see where it is and whether it's read-only or not to the cluster, which is just kind of useful for debugging and seeing what's around. By now, MariaDB should have probably be running. Status MariaDB. No, that is already what I typed because, yep. And then if we run the application, Nomad status 5482. Yay, that was fast. Then if we call the app, we see we just have this like counter. If we post to it, we increment the counter, all very simple. And then if we status MariaDB, if we then go and like force stop and restart that allocation, might also need to restart my like very hacky app. Actually, no, Nomad will have restarted it because it uses console for service discovery. If we take a look in 5482, yep, we see the console is restarting it because the template changed. And why did it fail? Oh, it would have failed because the thingy wouldn't have been available yet. Live demos are a mistake. OK, downloading image, Docker will do a thing. It started. And if we curl the thing again, we see that the data is still there because it remounted the same volume into the container. Cool. Demo kind of worked. Now I need to figure out how to make this present again. OK, yeah, Google Slides just killed the presentation thing. So if I press this again and then send this to that, no. But it worked a minute ago. I3 is a mistake, actually. Yay. I have keyboard shortcuts. I tested them earlier and they worked, and now they're working again. That's good. Cool. So, yay. Now, I hear people saying, but what about my precious NFS? Because everyone will have NFS somewhere. Well, in some upcoming release of Nomad, that is hopefully 0.11, we'll be shipping support for storage plugins. A lot of what I'm about to say is very early in development, and a lot of it is hand-wavy and may change. This is just giving you an idea of where we're going, and so you can come and talk to us in the Nomad booth, or right after this talk, find me outside, and we can talk about what people are actually doing and help us sort of design our roadmap for it. So what we actually wanted to be able to do is enable mounting volumes from arbitrary storage providers across all of our task drivers, and also add support for mounting block devices as opposed to just file storage. And we wanted this to have native scheduling integration with Nomad. So volumes should have identity. We should have support for different scheduling modes, single node mounting as well as multi-node mounting where possible. And also to have a way of handling failure in the scheduling layer in a way that is actually safe. Not all storage providers, for example, when a node goes away, will have a guarantee that something doesn't have a write path to that data, which is actually pretty scary and dangerous. Because if you have theoretically lost a node, if you're running in a cloud provider and your node says it's shut down, but it's not, and still can write to a volume, but also another node can write to a volume, things get really scary by the way this happens in production. And we also wanted to have some level of access control to these volumes. And the way we're probably going to do this right now is bind volumes to namespaces. And so you can benefit from the same level of control as you do with Nomad jobs in namespaces with volumes. Cool. And the way we're going to do that is by implementing support for the container storage interface. But I hear you say, what is the container storage interface? It is a standard interface for exposing storage volumes to workloads in orchestrators. And it was designed by a committee of people from Kubernetes, Mesosphere, Google, and a bunch of storage vendors. And it lets storage vendors write their own plugins that will work across various container orchestrators without having to maintain dedicated integrations for everybody. Which also means if we find if someone finds bugs in one place, they get fixed for everyone, which is pretty nice. CSI plugins are usually containers or sometimes binaries that expose a gRPC interface over a Unix socket, modulo upcoming support for Windows that'll do some other magic. This interface mediates between the containers, the constructs that an orchestrator cares about, the concept of nodes and a bunch of other stuff. And hides the implementation details of actually managing storage. inside the plugin itself. And it already has support from a bunch of many providers today. So like things that run on-prem, like Ceph and Gluster and Portworx, to like basically every cloud provider. And which means that like when we ship this, like wherever you're running, you can probably use it that day. So how is this probably going to work? When you're running a plugin, because we can't guarantee how a plugin will be shipped from a vendor, Nomad will not be required to manage that plugin for you. What we will do is we will introduce a stanza in the config that lets you give it a name and like tells us where to listen for it. And then if you want to run the plugin in Nomad, you can use host volumes to mount in the parent directory with a bidirectional mount. And then you can run that plugin inside Nomad. The downside of running a lot of these as Docker containers is it means you also have to enable running privileged containers on your nodes, which is pretty scary, actually. So if you want to, you can also run them outside of Nomad under like systemd or like wherever else you want. That is like up to you. And so like when you've told the Nomad client that a plugin exists, it will start fingerprinting that path and waiting for the socket to become available. Then when the socket's available, it'll talk to the plugin and like communicate a bunch of like information about the plugin, and then also it will get external metadata about the node from the position of the storage vendor, like its node ID and its topology within the storage system, and then makes the node available for scheduling of compatible volumes in the cluster. And then when you want to actually register a plugin, register a volume, because Nomad is not a universal control plane, we won't initially support provisioning dynamic volumes on the fly. What you'll actually need to do is register an existing volume from your provider. This allows us to reference the external volume and allow you to provide some metadata as to how it should be accessed. We'll then go and like validate all of that and make it available for like use in the cluster. You then bind the volume to a namespace with a claim that specifies exactly how that volume will be used and gives it a name that is common across all providers as opposed to one that is unique to a provider. And then in your job, just as we did with host volumes, you'll specify that a volume with this given name should be used in your job, and it'll just work as a host volume would. I thought I had another slide. I do not have another slide. But yeah. So how does this help with the scheduling problems that we see with our existence persistence options? With CSI, plugins provide all of the information we need to have the scheduling topology so we can automatically generate the constraints to schedule the volumes where they can actually be used. This makes scheduling onto like ineligible nodes basically impossible. And it also means that eventually, as the CSI specification evolves, we can theoretically also then generate implicit affinities to have better data locality if you're running like on-prem or whatever. And when it comes to security, we can also improve the status quo on Docker volumes here too, because we know about them now, which means they're bound to a volume. So now when acid burn comes to like take over all your data, it's just like, hello, give me your data. And we're like, sorry, the namespace you can submit jobs to, this volume doesn't exist here. Sorry, bye-bye. And then you try and submit to your sensitive namespace, it's like, you tried. Bye. Which is, you know, nicer than losing all of your data. And there are also many cases to talk about with fault tolerance when talking about network storage. Is the provider still reachable? Is the volume healthy? Is it even still mounted? Lots of these things are hard to manage when you're running things yourself, because like usually when you're running stuff like storage, like you only introduce monitoring for something like when it's broken before. And like that's something that like everyone ends up relearning themselves, and it's like really sad. Like in some cases, like volumes will just like go away. And like if you didn't expect that a volume would go away, you probably didn't set up alerting for that already. So the most common case that like we need to actually do something to bring your app back together would be like if your database crashes. And in these cases, like we can follow Nomad's existing rules for restarting and rescheduling the allocations, while the volumes can automatically be mounted into the new destination if we had to reschedule. And then you benefit from our existing monitoring of being able to see like what is broken and when and why. Then a bigger, more scary failure mode for data is when just like the node dies. Like whether it failed, whether it network partitioned for too long, like whatever happened. This is kind of a complicated failure mode because it somewhat depends on your storage control plane. So although Nomad already has a lot of controls around like when and how to reschedule and restart all of your tasks, there's maybe some like work involved here in introducing sort of like potentially some kind of manual recovery in some data providers in the case of like net splits, if we can't guarantee that a volume has been detached. And then we can also cover the cases where like your like access to the storage provider comes unhealthy, because we're fingerprinting and monitoring the health of the view from that node. If the storage goes away, like we can then go and reschedule your storage somewhere else, and like yeah, cool. I will wrap up. So in 0.10, we're shipping support for host volumes, which allows you to safely mount volumes from your Nomad clients into the tasks in a driver-agnostic way with a useful ACL system in a way that the scheduler actually knows about, and that is in beta today. And then soon we'll be shipping storage plugins that will provide native integration with external storage providers, with a lot of work around sort of like making that safe and fault tolerance and handling safe upgrades, potentially some kind of stable identity, and like out-of-the-box support for things like NFS, EBS, and Portworx. And that's coming soon. Thank you. Please come and talk to us.